702.
The Naked Scientist.
On Mondays, I just love this time in the show as we take your calls on science-related thoughts and questions and fascinations and musings you might have. And luckily, I don't have to answer those tough questions. They're all directed to my guest, and that's Dr. Chris Smith, the Naked Scientist. Hello, Chris.
Hi, Azza. How are you?
I'm very good, thank you. We already have your listeners, your fans lined up with questions.
Oh, brilliant.
Up to the task today. Let's go straight to the lines and start with Jane in River Club. Hello, Jane.
Good afternoon, Azania and Chris.
Hi, Jane.
Hi, Jane.
Chris, we were recently up in the Kruger Park, and so many people I have spoken to before we even went up were telling us how many hyena they'd seen. We were up there, and there were hyena literally everywhere. Everyone was seeing them. There were mothers with small babies, sort of medium-sized babies, then teenagers, then mothers. And I was wondering, because I've never seen so many before, and as I say, everyone's talking, is it possible? I mean, is nature so clever that, number one, either the hyenas loved no people during lockdown, or is it because they know, was there a drought, so there was lots of food that they had to clean up, or is there going to be really good food in anticipation of a great season? And kills. So I was just wondering, because as I say, everyone's talking about the hyena in the Kruger Park.
Hyena baby boom. All right.
I think there's probably a range of possibilities here, Jane. We know that all of the things that you have said make a difference to wildlife and wild animals. They move with the seasons. They move with good times and bad times. They congregate where there are food sources and they congregate where there are water sources. They will have more offspring when times are plentiful, when there is a lot to eat and a lot to drink and there's not many predators. And so you'll generally find that nature will go through cycles of boom and bust. There will be conditions that are really good for a certain group of animals. There'll be a big increase in that group of animals. Later on, when conditions are less favourable, the replacement rate in the population, in other words, the number of individuals who grow up and become adults, will drop. They'll have fewer babies, therefore the population goes down again. So all these things do wax and wane. And you've also got to be careful not to attach significance to coincidence. It's possible that because you went where people go where other animals go. Therefore, hyenas, which are cleaning up after things they can pick up to eat, will go where the other animals go. So there's therefore a bit of a self-fulfilling prophecy. You're seeing the snapshot of the Kruger, and lucky you, it's a beautiful place, that you did see, but there will be other areas that might have had fewer hyena in them. So I'd say all of the things that you suggested are certainly true, and this really points to the fact that nature is this really interconnected, rich web. And if you know with the spider's web, if you cut some of the strands, the whole web goes out of shape. And nature is very finely balanced, whereby you have producers, which are plants, which are capturing energy from the sun, and they're feeding the consumers, which are animals that eat the plants, but then other animals eat those animals. And the whole thing goes up in a so-called pyramid of numbers. And that pyramid has to be the right shape and size. Otherwise, it becomes just like a real pyramid made of stone, unsteady and would topple down. So therefore, nature is finely honed and finely balanced. And if we come in and disturb it, there is a real danger that what we can do is to introduce imbalance in nature. And that's exactly what we are doing around the world, which is what the point of David Attenborough's latest documentary he's released in the last week or so is saying, that we're having an irreparable effect on the planet, and we have to be really, very careful about that. But I hope you enjoyed the Kruger anyway, apart from there being hyenas everywhere.
Thank you, Jane. Thank you for your call. Listening in there. And next we go to Kumbu, who's calling from Broaderport. And you can also do the same with your science-related question for the Naked Scientist. 011-883-0702. Kumbu, hi.
Hey, good afternoon, Azza. How are you?
I'm good, thank you.
I'm all right. Good afternoon, Chris.
Hi, Kumbu.
Hi. You know what? I'm always fascinated. I mean, when you watch people's weight actually fluctuating. So, one wonders, how flexible the bones structure is of a human cranium. Is it flexible? Does it actually change according to the body weight? It always just fascinates me.
The human skeleton is a dynamic, metabolically active tissue. And when we're first growing, we lay down new bone, and then we mineralize the new bone. That means we make deposits of minerals, chiefly calcium phosphate, into the bone matrix, the proteins. And once you get to about age mid-30s, your bone mass peaks. And your skeleton is never going to be as strong again after that point, because after that, it stays the same for the next 10 to 20 years, and then it starts to disappear. And the things that shift, whether it stays strong or starts to disappear, chiefly are what you eat and what you do. And what you eat makes a difference, because if you have enough calcium in your diet and you have vitamin D in your diet and you're also exposed to sunlight, you will make vitamin D. And this influences how much calcium can be picked up by your guts, put into your bloodstream, and help to avoid using your skeleton as a source of calcium. The other thing that makes a difference is your exercise. And this is called impact or load-bearing or weight-bearing exercise. Bone, because it's a metabolically active tissue, responds to load, to stress, to impact, and that sends a growth stimulus to cells in the bone, which are called osteoblasts, and it makes those cells make more bone. And it suppresses the activity of other cells called osteoclasts that normally eat or break down bone. So the more exercise you do, the greater the stimulus to maintain a strong skeleton. And this is why astronauts, when they go off into microgravity and they're floating around for months on end in the International Space Station, have to be really careful, because if you remove that load-bearing, doing work against gravity, high-impact force on your skeleton, you remove the stimulus to keep the osteoblasts busy and the osteoclasts asleep, and your skeleton begins to erode. And you can, if you don't take proper exercise in space, which astronauts do by exercising against a fixed load like an elastic band or a spring or something, then you can come home with a very, very old skeleton, the skeleton that you would have to have aged for decades on Earth to have had the same level of bone loss. And the only other thing to bear in mind that really affects things are hormones. And women after the menopause have lower levels of estrogen, and estrogen has a growth-promoting effect on the skeleton and keeps it strong. So postmenopausally, when estrogen levels are lower, the skeleton can begin to weaken. And in men, testosterone helps to promote the growth of the skeleton as well, which is why men on average have a denser, bigger skeleton and grow bigger than women do, because testosterone promotes growth of muscles, and muscles exert forces over bones. So to carry bigger muscles, you need bigger bones. So all those things add up together to give you the way in which your skeleton behaves over your life. But certain bits of your skeleton don't change, and your skull, it's not normally load-bearing unless you spend a lot of time standing on your head. So your skull won't behave quite like that, but unlike other bits of your skeleton, your skull can still grow throughout life. And there are conditions, including one called acromegaly, where in response to an excess of growth hormone from your pituitary gland, you end up with an excessive laying down or deposition of bone in the flat bones of your skull, and you can end up with a bigger head than you would do normally. And you get a very broad forehead. It also affects the hands as well and some other parts of the body. But chiefly, yes, your skull is not going to change shape with load-bearing exercise because the stimulus isn't applied there.
Ah, fantastic. Kumbu, thank you for your question. We go to the Glen now with the question from Sfiso. Hi, Sfiso.
Hi, Aza. How are you?
Good, and you?
Hi, Chris.
Hi, Sfiso.
Yesterday, yesterday I read something fascinating on EWN regarding how they treat the dead, or they call them the carcass of a whale, that, instead of putting it back into the sea, at least that's what I thought. I mean, taking it back into the sea so that it sort of gets disposed of by the elements in there. They take it away to they call it a land, I think it's a land site, which I'm assuming that's where your normal rubbish would be taken to, so that it sort of, disposes, so it goes away from there. So my question was, why is that the case? Is it not easier to just take the whale back into the sea so that it sort of it's eaten up by other animals in there, or is it not an edible species, as it were?
Yes, it was such a heartbreaking story, so it played out over the weekend. A humpback whale beached in Strandfontein in Cape
Yeah.
Town. And obviously the relevant authorities were there. They brought out this huge truck that carries abnormal loads, and they loaded it onto the back of the van to take it to a marine dump site. And I do recall as well thinking a similar question about, such a space exists, where we take carcasses of marine life that is now dead. Such a space exists. So a great question there, Sfiso, because also this whale was said to be underweight, and that's concerning for its age that it's underweight, and maybe it's also affected by the amount of plastics that are in the ocean, which have affected its digestive tract. So it'll be interesting to see what the researchers pick up from what they find there. But what is the thinking behind this, Chris? What do you think of Sfiso's question?
Well, in the wild, of course, these animals, when they pass away, which obviously everything dies at some point, they would fall to the ocean floor. And when a whale dies and you get so-called whale fall, they deliver to the ocean floor enormous numbers of nutrients and calories, and they feed the ocean floor. But that's in the right place at the right time. An animal that's died close inshore, and we're not talking about a small animal here, just if anyone hasn't seen how big a humpback whale is, you're talking about something which is much bigger than a bus and weighs 40 tons, even if it's not huge, it may be 20 tons plus of animal. And you don't want that rotting away on a nearby beach because it will pollute the water. It will also attract the wrong sorts of fish, and I'm thinking of things like sharks. And it will also, if it's died for some kind of pathological reason, say it's got a disease or something, it could pose a threat to other species or even us. So it's actually safer sometimes to remove these animals, and also you've got the chance to study them. These are precious animals, and humpback whales have made quite a comeback. Since whaling was banned internationally, especially against that species, their numbers have really come back in a big way. And so we're not worried about them being endangered anymore, but every opportunity to study an animal like this is a golden opportunity. So if they do get the chance before disposing of the carcass to do a whale post-mortem, it means we have a chance to learn about a precious animal that we wouldn't normally have a chance to see in those circumstances. So there's a whole range of reasons why you wouldn't want to just dump that in the beach. You could tow it out to sea, but if you did, there's also a risk it could be a danger to shipping, because small boats and fishing boats and things could drive into it because the animal would just be bobbing around in the water, and it may cause, therefore, further onward harm. And so therefore it's safer under certain circumstances not to do that, just remove it, study it, and then safely dispose of it. No risk of passing on diseases or doing further onward harm to other animals.
All right. Sfiso, thank you for your question.
Thanks a lot.
Thank you.
Thank you. And then we've got Joe in Killarney with the COVID question. Hi, Joe.
Hello, Azania. I'd like to ask Dr. Smith about the coronavirus. How long does it remain in the body with complicated lower respiratory tract infection, and the value of the serological test used currently, say a good quality serological test?
Okay, well, first of all, how long does it stay in the body? An uncomplicated case first. Let's start simple and build up. So if you have an uncomplicated case of COVID, then the virus infects you. The mean incubation is about a week, and then you feel grotty for a week, and by about 10 days after the symptoms have started, the virus is gone and you are regarded as not posing a threat to anybody, and you can go out and about and go about your business. That's not to say that if we didn't look hard enough, we might find some vestige of the virus just clinging on, and it takes maybe a week or so more before it completely disappears, and in some people a bit longer, but in most people 10 days and you're absolutely fine. Now, there are people who get some kind of long-term COVID infection. These people usually have a problem with their immune system. And we've had a couple of patients like this in our hospital. They've had either a prior transplant or they've got a pre-existing inherited immune disorder. And this has meant that they can't make the normal immune response. And in those people, the virus just continues to grow out of control unless we go in and do something. And in those people, we've helped them by giving either antibodies from other patients who have recovered from coronavirus infection, and that's helped some of them. Also, the drug remdesivir, which is made by Gilead Pharmaceuticals and is undergoing clinical trials and evaluation for treatment in COVID at the moment, does appear to work under these circumstances and can help the patients to clear the virus from their body. Left to its own devices, it appears that it would never be removed from the body under certain circumstances in these patients. So the answer to your question is a hard one to answer with precision, because in an uncomplicated case, it's 10 days or less. In someone with an underlying immune disorder, the answer may be never. And in someone who goes on to develop very severe disease, we don't actually think the virus causes the severe disease. It triggers the process that then causes the severe disease, and that's an immune tailspin where the immune system goes out of control and starts attacking other parts of the body. But we don't think the virus directly causes that, and so probably the answer is going to be very similar. It comes along, causes the immune system to become overexcited. The immune system gets rid of the virus, but then the immune system continues to damage other parts of the body in people who go on to develop very severe illness.
There we go. Joe, thank you for your question. And next we have a 9-year-old. Litlotlo, hello.
Hello.
How are you?
Fine, thanks, and how are you?
I'm good, thank you. So you want to speak to the Naked Scientist? You have a question for him today?
Yes.
Go ahead.
Why is the sky so blue?
Why is the sky blue? A wonderful question.
Yes.
And the answer is, if you look at the sunshine, the sun makes white light. But there's no such thing as white. When we look at the light coming from the sun, it looks white because that's a mixture of all of the different colours of light that we can see all mixed together at once. When that light reaches the Earth is surrounded by an atmosphere of gases, and about 80% of that atmosphere is nitrogen, about 20% is oxygen. And it just so happens that light that's at the blue end of the spectrum, the blue-coloured fraction of the white light, the waves are about the same size as the bonds that hold together the oxygen and the nitrogen molecules that make up the atmosphere. And that means that when the blue light hits the atmosphere, it gets scattered, a bit like a bullet ricocheting round a room. So when you look at the sky, you see blue light coming from all directions. And so your brain concludes the only reason that I can see blue light coming from everywhere must be that the sky is blue. So you think the sky is blue. We know, of course, the sky isn't really blue because when the sun goes down and you see the stars look white. Now, if the sky were blue, the white light coming from the stars wouldn't look white, would it? It would look blue. And it doesn't. The sky looks black and the white stars are a white colour. So that means that the blue sky is an optical illusion because the blue light's been scattered all over the place by our atmosphere.
Optical illusion, Litlotlo. Thank you for that question. We wrap up quickly with a question from Lebo. Hi, Lebo.
Hi. I just have a question for the Naked Scientist. This is in relation to the application of probiotics, probably in deodorant, literally without having to use chemicals. Now, we know that the sweat itself doesn't smell, but once it gets combined with the microorganisms in the armpits, that's what actually causes the smell.
Yes.
So without having to use deodorants that have got chemicals in them, would the probiotics actually work?
Okay.
Hi, Lebo. The answer to this is that it's actually very difficult to suppress the microbes that make the whiff. The whiffy bits of your body tend to be the areas where you have a lot of what are called apocrine sweat glands, and they make a very greasy form of sweat that feeds microbes really very well. And it's therefore going to select for the kinds of microbes that eat it very well and produce whiffy compounds. We partly combat this by having a regular wash and a bath to wash away the smelly stuff, but also wash away the bacteria themselves. It's not beyond the realms of possibility. You could encourage other bacteria or microbes to grow in these areas that would help to keep down the whiffy ones, but probably because they're being fed a diet that they really like, it would encourage the growth again of the ones that make whiffs and suppress the growths of other kinds of microbes. So I think it's a laudable aim, but unfortunately I think it's going to be very difficult to do
Okay.
sustainably. And for the benefit of all of those around us, we tend to adopt deodorants as probably the safest option. But if you come up with a way
Yes.
that works, do let me know. I'm always willing to give things a go.
Yes, so as that thought develops, Lebo, and any insights you'd like to share, please come back to the segment of the show. Chris, as always, a pleasure and a joy to be with you.
Likewise. Thanks very much, Azza. Thanks for the questions, everyone, and keep them coming.
Yes. Keep them coming every Monday with Chris Smith after 2:30.